Okay, so you just wait a few seconds. Let me also open recording on the other platform. Okay, so there are other people on 10-cent platform. Some are here on Zoom. So welcome once more. If you're just joining us, welcome. This is day 4 of our OSCC 2023 program. Tomorrow is the last day, and we are excited that we have reached this far with the consistency of at least 100 persons joining the platform every day. So looking forward to a wonderful day 4 and a very impactful one, which I can foresee in a few minutes. So without much delay, let's get our welcome remarks from special volunteer Nakili NC Hoda. Nakili, if you are there, you can please unmute yourself and welcome us.
I'm here. Good afternoon, good morning, good evening, wherever you are. Okay, my name is Nakili, and I want to say on behalf of our boss and the team, we are here today to welcome you all as a participant in our online Summer Computer Concepts, which is OSCC 2023 training program. We want to appreciate your commitment thus far, as today is the 4th day of our training. We want to appreciate you all for making time and leaving your busy schedules in making this day a success. Because, we've asked you guys these past days who have been successful. We also appreciate our boss, Mr. Orlando Teah, for letting us all the opportunity to be on this platform today. We encourage you all to keep being focused as we provide you with a comprehensive understanding of various concepts and topics that form the backbone of computer science. And I'm so happy that at the end of this training, you all will have a very solid foundation in fundamental principles of computer science and be equipped with the practical skills necessary to tackle real-world challenge. You are all welcome once more, and you are all loved by TRT members. Welcome, one love.
Okay, so that's a welcome, one love. Thank you so much, Nakili, for welcoming us. Let's move to our next session. Taking the overview of TIT. I'm going to play this video.
Teah Innovative Tech. TIT, with the color representation of green, blue, and white. It was founded in 2018. It is our vision to use technologies to transform lives. There are lots of great minds out there, but the opportunities to learn and grow haven't been presented to them. TIT will use technology to provide career guidance, personal development, national transformation, tech events, and much more. TIT is operating on these 4 pillars: develop, build, connect, and impact. These pillars can be applied to individuals, groups, companies, nations, and society at large. Activities of TIT since its establishment have been: 1. Personal development of the founder in terms of higher education and networking with great minds. 2. Producing educational videos about computer science or tech, networking, windowing, programming, IoTs, web development, etc. These videos are being uploaded to TIT various social media platforms like WeChat, Facebook, YouTube, etc. 3. Organizing special classes or tutorials for individuals among others. 4. Web development projects. 5. Conducting global webinars, which are done during the winter and summer seasons, and many others. The prospect of TIT is to establish a free online learning platform and technical schools throughout Africa and the world. The takeaway for the audience are: 1. Exposure to a certain domain, some might be in a state of dilemma. 2. Career or educational guidance. 3. Hands-on from the speakers, practical tips, tools. 4. Connections or networking with like-minded people within the industry. 5. Certification. 6. Future partnership. TIT is open to partnership for the betterment of humanity and society. We can only have a minimally criminal-free environment, job opportunities, small businesses, entrepreneurship, and a vastly growing economy when the minds of young people are geared toward finding solutions through the use of technology. Where there is a lack of creativity and innovation, the nation and its people are doomed to stagnation and economic hardship. So, join us at TIT as we develop, build, connect and impact.
That's it, guys. Join us. Let us make an impact for our community and society at large. So the last 2 days, we had one of our own Nigerian brother here in China for Bosco. We talk about his music, the brand and the name. And he had, I think it was 69 or 64 subscribers, but then we pushed it up to 77 yesterday. And we hope that other people can as well follow. Maybe by the end of today, we can also check again to see how many persons are follow. We have played his music, you listen to it. Obviously, you know it's a good one. So keep subscribing, keep following, keep supporting him. His type of music is also a master degree holder in environmental engineering. So it's not just music. Let's keep showing love and keep promoting him. Also, yesterday, we talked about the Huawei developer competition. And this competition registration will end on August 13th. So you can be able to deploy, build and manage your application using the Huawei cloud service. And if you want to join a group, you can scan the QR code to join the WhatsApp group. As of yesterday, there was 126 persons in the group. And each group, if you want to register a group, you guys can be 5 in a group. Or if you want to go as an individual, that's also fine. So, but just know that the limit for the group is 5 persons. These are the details about how things are going to unfold. 9 teams will be qualified for the grand jury in Shenzhen. Your flight and accommodation will also be covered by Huawei. You don't have to worry on that. All you have to do is just make sure you reach to the grand final, and they will pay for your air ticket and give you accommodation. So the grand prize will walk away with 10K USD. They only need 1 team for that. And the first runner-up, they need 2 teams, 5K each. And each of the winners will walk away with a certificate, trophy, and a promotion. So second runner-up, they need 3 teams, 3K each team, and also honorable student award. They need 3K as well. I mean, they give you 3K, but they need 3 teams as well. So each team will walk away with 3K USD. So you can take advantage of that. Who knows? Walk away with 10K, 5K, or 3K. That might at least help you to start a business, start life, or maybe add up to whatever you are doing. So take advantage of that. These are our volunteers that have been working so hard throughout the entire session. Even before the session, the planning and everything, they have all been working very hard. Some of them are here on Zoom. Some of them are also on Tencent meeting because the program is being relayed also on Tencent because Zoom couldn't hold all of the people that will join. So we incorporated certificate verification on the website of TIT during the winter's edition. So by tomorrow, we'll start issuing out the certificates at the end of tomorrow's session. And you can just visit the site. The URL is below here. Just go and enter your certificate ID. And then you're going to see your name and every other information as it relates to this session. We have had Mr. Yemen who spoke on cybersecurity on the first day. And then Ada spoke on artificial intelligence, and ChatGPT as well, with other AI platforms. Yesterday, we had Anna, who spoke on networking, basically system administration and just some concept as well on networking. Today, we're going to have a combined speakers, Israel, and our other brother, that's a secret. So you're going to be hearing from them shortly, and also they will be introduced by one of our volunteers.
Branford.
Hello?
Yes, I was saying Branford.
Yeah, no, I will get it, I know. So one of our volunteers will be introducing the speakers shortly. Tomorrow, we'll be having Dr. Haji. He just messaged me not too long saying he's ready for tomorrow. And I'll also be excited to hear from you as well. So the certificates for the speakers, volunteer, and participant, they are ready as well. Let me see if I can show you. I was just trying to welcome them. These are for some of the participants that I was convinced and sure that they will end all of the 5 days. So in advance, I try to prepare the certificate because we issue certificate immediately after the program. So by tomorrow, right after the program, you start to receive your certificates via your email that you submitted, or you can tell us if you want to receive it through WeChat, WhatsApp, or however means you want to receive it. So I just prepare some of the people. If you're not seeing an email, don't worry, we are just preparing it. And also I've done the same for all of the speakers. Their certificate are already here. And then all of the volunteers, the certificate are here as well. So the only people that are left are you, our participants. So make sure you complete today and complete tomorrow to be qualified to get a certificate. So if you miss today or you miss tomorrow, then unfortunately you will not be among the people that will be receiving certificate. So on the certificate, you'll see an ID on the certificate. Use the ID to verify a certificate via the website. So you just check here on the certificate will be issued to you, and then you can use that to verify a certificate. So for TIT platforms, to visit the website of TIT, just visit titnetwork.org. It'll take you there, and then on training, you can be able to see the certificate verification system there. If you're not in the WhatsApp group where we share the daily attendance, a way for you to know if you attended out of the days so that don't affect your chance of getting a certificate, you can join the WhatsApp group. If you are out of China, or even if you're in China, no problem. But if you're in China, you can scan my QR code to join the the WeChat group. Send the group, I see that more than 200 persons. So you can only join by invitation. So that if you scan my QR code there, I'm going to add you to the group. There's also a WeChat channel. You can scan the follow the channel. Currently, we are more than 1,000 followers on the WeChat channel. The Facebook page is there. The YouTube channel is there. All of the videos from previous sections, they are all there. The videos for day 1, day 2, and day 3, they are also on the YouTube channel. At the end of today, the session will also be on the YouTube channel before 12 a.m. China time or before 6 or 7 o'clock Nigeria time. So let's welcome Alice. We have had Alex. We have another Alice. Today again, there's another Alice. Our volunteers, so many AAA, and the list keep going on. So Alice, if you are there, please unmute yourself, and then you can introduce. Our speakers for.
All
Alice,
right, thank you so much. Yeah, I'm here.
okay, go ahead.
Thank you. Hello everyone. By names of Alice Francine. Welcome everybody to our day 4 of OSCC 2023. As of today, I'm going to introduce our speaker for today, and he is by names of Israel Kollie. He is an experienced system developer, user data management, and health emergency system development. He is expert in regional databases, data visualization, system integration, and apps development. He conducts technique app programs monthly in Monrovia.
Okay, so that's one of our speakers. Today's going to be a collaboration. And that's the unique part about today's. We're going to be having Branford, who's going to be alongside Israel to talk about data systems. So the profile of Branford is here. He's an AWS data analytics subject matter expert, a data engineer, cloud architect, 5X AWS certified, Terraform certified, GCP, DevOps, IGO, advocate, Scrum Masters, and he's an entrepreneur. So without further ado, I want to invite both of them. I don't know how they're going to do it today for us, but I want to invite both of them to the platform so that they can give us what they have for us today. Israel and Brent, are you there?
Yes. Hello, everyone. As the moderator said, I'm Branford T. Gbieor. The last name is pronounced as Gbieor. And I'll be working here today with Israel. So, Israel, maybe you can come in, and then I'll come after.
Good morning, guys. I hope you can hear me loud and clear. This is Israel. I'm speaking to you from Monrovia, Liberia. It's good to join you guys today. I've been following the rest of the presentations from the beginning, and I hope you have been learning a lot over the past few days. So today, Branford will be doing most of the talking, but I'm here. I will be along with him. So, Branford.
Okay. Thank you so much, Israel. I will share my screen. Within the slides, I don't have much about myself, but I will say a bit about myself before we move on. Let me know if you see the presentation.
Yes, we can see it.
Okay, so as you said, today we'll be having a discussion around data systems and modern approaches to how Fortune 500 companies, startups, are approaching the development and the management of their data and their data systems. So I might narrow this down to a few technologies and a few discussions, but let me say this: I'm open. Israel and I are open to questions. So feel free to come in with questions. It might not be questions that you should have or you could have from the slides or the presentation, but it could be questions around data systems, data and cloud systems. Let me briefly say a bit about myself. Again, I'm Branford. I currently work as a senior data engineer for Last Mile Health. Last Mile Health is a global health organization. But before then, I've been working with global organizations in the past. I've done some consultancy work. I've worked with some fintech startup in out of Liberia. Um, Actually, I have my background in um, electrical and computer engineering. Um, but I'm a software engineer. I've been working as a software engineer for the past 10 years. I've written a lot of international certifications. Specifically to AWS, I have 5 AWS certifications. I'm a solution architect professional. That's the highest certification in AWS. And some of you don't know what AWS is. It's a cloud computing platform. It's the biggest. If you look at the Magic Quadrant, you see that AWS is the leader in cloud technology. So during this discussion, I must say a few things about cloud, because again, we are approaching data systems. We are kind of applying modern approach to data systems, or we are approaching data system in a modern context. So these are the 3 things that I'll be talking about today. We'll talk about relational database systems, ones that most of us who have been around tech for a bit should have some understanding about. It's the most common one. We'll talk about data lakes, and then we'll talk about data warehouses. And I'll kind of shine on light, even though it's not in the slide. I made the slide as brief as possible, so that it's not too crowded, so that it's easier to understand by even non-techies. However, at the end of the presentation or during the presentation, I'll keep stressing on how we can integrate these different techniques to have a complete system end to end. And this is what my current organization, this is the work that I'm currently doing at my current organization. We have integrated these 3 techniques, technologies to have a complete system end to end. So we're talking about relational database system. What it is, what are the benefits, the drawbacks, and some of a scenario. We'll consider scenario for each of these modern scenarios, so that the audience can have a bit of a grasp as to what is being discussed. We'll talk about data lake. We'll talk about data warehouses. So we start with relational database systems. A relational database system is a way that we kind of structure our data in tables, rows, and columns. Some of us, as I said, who have been around tech, we can start to consider we can consider a system as simple as Access, Microsoft Access. It was popular in the past. A lot of people use it. A lot of big organizations use it. And so some of us might know a bit about Microsoft Access. What we do in Microsoft Access is we define our database, and then we define our relations. And when we say relations, what we mean, we're actually talking about the database tables. So simply put, a relational database is a database. It's where you have a repository, and then within that repository, you have tables that are related. That's what a relational database is. That's why even the term relational is there. There's something called relational modeling. Relational modeling is understanding your specific objects that should be within the database and how these objects are related to each other. So that it's easier, so that data access is easier. So what do I mean when I talk about modeling your objects and then identifying how they are related? There's a technique that we use called, for example, we call ER diagram. I don't know if some of you have heard about ER diagram, but basically You can use a modeling tool. For example, Lucid Chart is a tool online that can be used to kind of design your objects and how these objects are related. Let me give a quick example of a relational database. Say we have a school now, and we're trying to develop a database for that school to store their data. So we say we have the database XYZ school database. We develop the database as a repository to hold our relations. Remember, we say our relations basically is the tables. So within our repository now, we start to identify the objects that would be our relation, or that would serve as our relation, and how each of these objects are kind of related. So we develop a relation or an object for courses. We develop a relation for students. We develop a relation for teachers, and etc. etc. Now, then we start to identify now. After identifying the objects, we start to identify how each of these relations now, or how each of these objects relates to each other, or how they are related. So an example could be a database table, or a student would take a course. So a student is related to a course, right? That's the relation there. A student takes a course. A teacher teaches a course. Also, that's a relation between course and teacher right there. So once you start thinking about designing your database system in that format, then data access becomes easier. I know we'll have a general question and feedback at the end of the presentation, but I want to feel that people are a bit involved. So if you have a big question, please feel free to come up so that I can clarify. Then we'll have a general discussion or question at the end. So as I was saying, that's how we kind of model our relationships or our objects and identify their relationship. Now, somebody will ask, why can't I just have a single table with all of the data set within a single table instead of having numerous tables with relationship? And I mean, it's fair to ask that question, especially if you are just new entering into the technical space. And someone actually asked me that question before, a non-technical person who were in your most senior management role. There was a time that we were working on a project, and then the backend data system for that project had about 169 tables, and these tables were related. They were kind of interconnected. And the response I gave is this: we don't have a single table because in database systems we have something called the OLTP and OLAP. As I move on to the discussion, I'll talk a bit about OLAP, but now I'll talk about OLTP. OLTP is online transaction processing or online transactional processing. Basically, what that means is a database or a data system that's optimized for writing purposes. That's what it means. So it's just to process transactions. An example, take for example an e-commerce store that has millions of customers around the world. Every time these customers interact with the application, they are performing some operation with the database in the backend. So you have thousands of writes being performed at the same time, or millions of writes, depending on your customer base. So your backend system has to be as optimized as possible to handle these intensive writes operation. On the other hand, the OLAP, when I move to data warehousing, I'll talk more about OLAP, online analytical processing, is meant for read intensive or for reporting purposes. So there are different approaches that we take towards that. So basically, that's a brief say about database systems. I'm sorry, hold on. Give me a second, please. I'm so sorry for the interruption. I'm so sorry. I'm actually working from home today, and I got a bit of interruption. Lastly, before I pass this slide, there's one more thing I wanted to say about relational database systems. Usually in corporate environments, we have servers, right? If you have like tens or hundreds of people using a database, for example, then you can have it installed on individual computer. So we have specialized computers. So we have, do you hear me? Am I clear?
Yes, yes, yes. I can hear you.
Yeah, Branford.
Okay. So we have specialized computers. We have specialized computers designed for handling or hosting these database systems so that it's easy for multiple users to access the system. And these special computers, we call them servers. I guess most of us are familiar with servers. So back in the days, the plan was, even nowadays, we still have a lot of companies that still have their database systems on premise. Having a database server on premise means you buy a physical server. Um, you buy a physical server, and then you host it on premise, right? You set up your server on premise. You run all of your local networks on premise, and then people come to work and access the system. So it's not easily accessible out of the corporate environment. A lot of banks here also have their servers deployed on premise, so that it's accessed internally. So that is why the upper diagram is showing. But basically, other approaches now to database systems, for example, the cloud approach is buying your database server in the cloud on demand, and then having people globally access that system. It's also possible to have your system deployed on premise being accessed globally, but there are technicalities involved.
Benfo,
So, yeah,
it is permissible to ask questions while you are presenting?
yes, absolutely, yes.
So for the sake of somebody, like you talk about on-premise and the cloud service,
Yes.
what is the advantage maybe to SME or small or medium-sized enterprise business if I want to have my own database? What's a recommendation? Should I use the cloud or should I have it locally or in premise?
Okay, this is a very brilliant question. A very, very brilliant one. Okay, so let me say this. First thing first is companies that are implementing their on-premise servers or buying servers to deploy on their corporate environment are companies that have, to some extent, are big companies. When I say big companies, what I mean is are mature companies that are already established, have a lot of data, and have a lot of money on the average. Because to buy a server to set up your on-premise data center is very, 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 very expensive. That's one of the advantages the cloud brings. You have to buy physical computers that have high processing power, and these computers are very expensive computers. Besides, these computers having high processing power, you need specialized skill set to set up these systems on premise. You need system administrators, you need system engineers, you need network engineers. All of these people will have to come and set up the system. So basically, you get the physical server, you bring all these specialized skills, they will come and start setting up, for example, even the system administrator will start setting up or installing software and tools that are required for your system, for your database system to run. After you have spent all the money to set up the system, you will need to employ people who will be there permanently to maintain these systems. All of these are very, very, very expensive endeavors to undertake. So my advisory to small businesses and startups is that's why the cloud comes in. It's cheap. It's the time to spin up your resources is very short. Within a few minutes, you can have your database server running in the cloud. You don't need to buy any computers. All you have to do is just rent the computers from a cloud provider, and it's very cheap. When I say cheap, I mean very, very cheap. For example, if you open an AWS account and you're still within the free tier zone, you have for 1 year free access to run certain resources at certain scale or minimum scale for free. So for example, if you open your AWS account, you can spin up your EC2 instance, settings EC2, for example, T2 macro for free. You can spin up your RDS instance or your relational database instance for free, at least at a certain scale. So for small businesses, I would advise that you set up your system using cloud. It's cheap, it's easy, and it's easier to manage. In fact, they manage all of the overhead for you. All you do is just go for a few clicks, you have your database.
Yeah, and Branford.
Yeah.
So one example I will give is at Orange. So you know, Orange is a very big multi-billion company. So they have these data centers that they built. So all of the servers, the data integration, all the storage, everything is they are stored within the data centers. So you have these network engineers, these systems engineers that are there, to manage all of the softwares, I mean, all the configuration and everything. So you have to have physical people on ground to manage all of the hardware, the softwares, and all the configuration, the setup, and everything. Unlike the online where it's just a matter of clicks, and in a few seconds you have your systems up and running. So it's with a small company.
To that effect, considering security and budget, do you think it's recommended for institutions like banking institutions and maybe academic institutions to migrate to the cloud concerning their databases, or they should focus on having their own data center, considering security and budget?
Okay, so that's an excellent question. Let me move to the next slide so that the scenario I was bringing up was something similar, right? So the first thing is people used to believe that having your system on premise gives you more security. Of course, every approach has its own advantages and drawback, but the one we push for is the one with more advantages, and that's the cloud. Now, having your system on premise provides some level of security, of course, but within the cloud context, cloud vendors provide more security, I would say. And as a solution architect, I've always said this, and there's an argument that has been around, but a lot of professionals now in the field, or a lot of experts in the field now have started to agree. That is why you have a lot of banks, a lot of top banks and financial institutions now have all of their systems in the cloud. So I didn't mention the third approach to managing your system. You have your on-premise, you have the cloud, then you have something called a hybrid. Hybrid means you have some of your workloads on-premise in your environment, and then you have some in the cloud. And this is a complex environment is done for this disaster recovery purposes. Again, most big company, telecommunication company, from the example Israel gave, they have their system on-premise, but they have some system in the cloud. So you have that interoperability between, or that connection between their cloud system and their on-premise systems. Now, going to the issue of security that you brought up, there's something called SLA, service level agreement, provided by each of these cloud service providers that tell you the level of security they are obligated to provide for your data. Aside from these SLAs, there's another thing called the share security model. It tells you also to which extent you are responsible to protect your data and to which extent this cloud vendor is responsible to protect your data that you put on the cloud. Aside from that, these cloud service providers also say we have zones, we have regions, we have availability zones in which we replicate your data. So for example, if you are from the China region, they have a region there around China. I think Southeast Asia also. Within that region, they have multiple availability zones. Each of these availability zones have data centers, very big ones. Data center, it means very gigantic data centers. So what happens is if you put your data in the cloud, and for some reason, maybe due to natural disaster, one zone goes down, but data is still within another zone. So that replication is available. While on-premise, depends your strategy. If you have your data on your on-premise but being backed up to the cloud, so that just in case of any natural disaster within that region, for example, say Orange have that data center set up at their office in Gbieor, and maybe, for example, there's some unrest, God forbid, or there's some natural disaster, all of that data, the servers go down, all of the data goes down with it, except if they have that data being backed up to some other data center that's very far away from this region, and that is what the cloud also provides. So generally put, there are challenges with having your data in the cloud and challenges with having your data on premise, but there are more benefit and security to having your data on the cloud.
Okay, thank you.
Now let me talk about this scenario. Say you have your application, and all of the scenarios I will give here is within the context of AWS, because I'm an AWS guy. I mean, of course, I use other cloud platforms, but more focus with AWS. Now, we're talking about availability zone. Say there's the entire region, right? You have your availability zones, right? Availability zone A, availability zone B. You have your application servers, right? You have users from around the world accessing your application. You have this one database server spin up for your application. Let's assume you're a small startup. You don't have enough money to spin up very big servers in multiple availability zone. So you spin up your small server here, you're using it. Your data here is being synchronized. So there's something called multi-AZ. So you have your data server here. For the data here, this server, you have a standby just in case this server goes down, right? So this is an SQL server, for example. All of the application servers are accessing this SQL server. All of the requests from clients around the world are coming directly to this SQL server. Let's say, for example, there's a problem with this availability zone, and so your database server crashes. For example, let's say natural disaster, and this region and this availability zone goes down. What happens is the request from clients. Sorry, I don't have animation to show the switching, but automatically requests from clients or from these application servers will switch to your secondary server automatically. So this is clearly indicated here. You have these two say availability zones, even though here is showing regions. So you have maybe in this region and in this region, you have your server here, or you have a server here. Just in case the server goes down because of some problem, you can switch on to the server. That's how we call replication. You can call something they call cross-region replication. We get cross-zone replication and cross-region replication. This is how much security you have on the cloud in terms of managing your relational database systems. There are some flavors of relational database system to not get things confused. Initially, I started talking about access, but we have SQL Server, we have Oracle, we have PostgreSQL, we have MySQL, all of these are flavors to relational database systems. So I'll just quickly scan through the benefits and the drawback. Then we'll move to the next, which is our data warehouse, our data lake. Now, the key benefit is the relational database model is that it provides intuitive way for you to represent your data. So again, data is stored in tables, which is rows and columns, and it's very easy for us to understand of kind of access our data when it's stored in rows and columns. As soon as you see your table, you see, for example, the header. This, for example, the student table, you have the student name, the student ID, the student phone number, and the student address. You'll see all of the data outlined there, and it's easy, very easy for you to kind of understand what's going on there. These are not all of the benefits. I just took just one for the sake of time. The drawback is to set up and maintain a relational database is expensive. But again, it depends how you are setting this up. With the emergence of cloud technologies, it's a bit easier now. Not super expensive as it used to be. Even though there are still a few challenges with setting it up, even in the cloud, because it requires technical expertise. But it's a bit easier now as compared to before. Our next topic is data lake. I've been hearing about data lake. What is data lake? A data lake is where let's assume a data lake is a literal lake where we have everything that we have, fish, we have whatever we need there, right? In that lake, we have crawfish, we have all of the water related food that we need within that lake, right? In order to make use of that food, we have to go there and catch those fish, take them home and process them, right? So that's like a lake. Now, when we go there and catch these fishes or these crawfish on scale, take them to the factory, process them, and package them, take them to the warehouse. Then that's a data warehouse. We'll get to that end, but I just want you to understand that a lake is the more raw approach to a warehouse, where you have everything, data coming from everywhere in raw format, just being dumped there, right? So there's an advantage to having a data lake, because then analytics, right? Like free data access, right? People go there and just play around with data mining, right? Real-time data movement. You can even move your on-premise data from there. You can move your IoT data coming from your IoT devices there. And it's easy for data scientists. We have been hearing about data science, data science, data science. This is the main power of data science and machine learning. It's right here from the data lake, where you have huge amount of data set just sitting there, unprocessed data set just sitting there waiting to be explored, right? So if we say like a data lake, it means we have all kinds of data from everywhere. It could be image data, it could be video data set, it could be data coming in JSON format, it could be data coming in CSV, data in packet, just whatever you think about, you can dump it there. So that it's easy for people to go there and build models for machine learning and also perform some real-time analytics using tools such as Jupyter notebooks, etc., etc. So that's what a data lake is. Where you have simply put, you have all of your raw data set from everywhere, all kinds of data sets just dumped there, waiting to be used. So simply put, that's it. I have a scenario here for data lake, but if there's no question from this slide, then I can move to the scenario. So that will provide more context. Okay. Now, here is an example of a data lake, right, on AWS again, on the AWS cloud. We have our on-premise data center, we have social media data coming in, and the social media data could be images, click streams, let's just say streaming data coming in also, right? And there's more. We can have IoT data coming in. For example, you have small devices, smart devices that are interconnected and sending data, real-time data. They can all come into the lake, right? So from the data lake now, we have, for example, we have a few specific services that are being used on the hood for a data lake being set up on AWS. S3 is a very important part. S3 is an object store. It's a bucket where you store objects. So all of this data comes into an S3 bucket. Let's say assume this is a raw bucket. Comes into the raw bucket where we have all of our crazy data set. Then you can perform an initial preliminary operation on that data, right? Or minimal transformation and just have it in a process format. That transformation or that operation could be maybe kind of gathering your data set or changing the format from, say, the data is coming in CSV format or JSON format. You can process it and change the format into a standard format, say into Parquet, so that it's easier to be processed by data scientists. You can categorize your image data. You can categorize your video data set. All of these small minimum operations can be performed within the data lake, so that it's easier to be accessed. On the other hand, the data warehouse require more processing. Remember the scenario I gave of the lake where the fish is, the crawfish, everything there. You just have to go fish them out, take them home, and do your own side processing. So there are some days the fishermen are going to the lake to catch a fish. These single fishermen are data scientists, are data analysts that go there and just play around with the data, do some data mining to understand. On the other hand, the data warehousing is different, where you have a company or fishing company goes there, catch the fish, they don't carry them home. They carry straight to the factory, process it, package it, and then arrange them in the data warehouse so that it's easy to be transported, it's easy to reach consumers. So the end of the spectrum, where you have the value layer, that's where you have QuickSight. That's a visualization tool. But business BI analysts can perform operation here using this. You have Redshift, is the actual data warehouse. You have SageMaker for machine learning purposes to be consumed. So this is the idea behind our data lake. If there are questions, I'll take questions. If not, then I'll move to the next, which is the advantages and disadvantages, and then we can move to data warehouse, which is the final part of our discussion for today. Okay, so we can move forward. Now, the benefit of a data lake, it's a free zone, so you can dump whatever you want there. So we talk about scalability. You can dump petabytes and exabytes of data in your data lake. Yeah, whatever data. You can put a video that's over 100 gig, right? That's just waiting to be analyzed there. And it's low cost. Object stores usually are low cost, from AWS to Google Cloud Platform to Microsoft Azure. Everywhere, all the cloud service providers provide these storage, these object stores for cheap price. The drawback here is the complexity, of course. Again, a place where you are dumping everything is a bit complex to access data from there. And also there are data quality issues because, again, remember we said data coming from all sources across, right, the globe, your systems. It could be from your on-premise system, it could be from IoT devices, it could be from social media. They are coming in there. So there are data quality issue that needs to be addressed. Because, again, we said this is the raw zone. This is a free flow zone where we just dumping stuff waiting to be explored. So that's one of the drawbacks of a data lake. Then we move to the data warehouse. So I'll revisit our scenario of having a lake. Again, this company goes to the lake, right? Has our employees. They are all well organized. They have all of the tools and equipment required to catch fish and crawfish on a bigger scale. They go there, they grab these fish from the data lake, or let's say the data, they collect these data from the data lake, they process them, right? Process them and organize them, and then package them now in where? In the data warehouse. So the issue of collecting data, right? Let's say from the data lake, processing that data into something standardized and packaging it in the warehouse, it's called ETL. That's what we've been hearing about, the ETL. ETL stands for extract, transform, and load. So you extract the resources or the data, the raw data, you transform it, as the processing part. Then you load. The loading part is when you actually package now this data set in the data warehouse, right? So that's where the entire ETL process comes from. Now, this is the best part now, or this is the best place now to build all of your reports. Remember, we said the actual end users of a data lake are data scientists. These are people that require. That's why data scientists are hard paid people, because they require specialized skill set. You require a lot of some basic mathematics. You require some sysadmin. You require a lot of skill sets. So these are special people that are going to the data lake to kind of build machine learning models.
Branford, please unmute. I think there was some feedback somewhere. Branford? Branford? Israel, are you there?
Yes. 1 second. He is trying to unmute.
Okay. How long have I been muted?
No,
For
I
a few
think we're
seconds.
Okay.
You can proceed.
Okay, good. I thought it was for long. Okay. Okay. I'm at the final point now. So again, as I was saying, the data warehouse now is where you have the process data. So it's easier to access. It's very easy to have things very organized. So let's take the data consumer from the data warehouse as the end users, or as a consumer on the market who goes into the store and purchases a carton of fish or a carton of crawfish. This crawfish or fish has already been processed, has been frozen and stored. It's easy now to access and use. On the other hand, the data lake is a bit complicated, so that specialized people can go there. For example, if you say go into the lake, you need a fisherman who understands how to catch fish, who has a specialized skill set to catch fish. Anybody can just go. I mean, you can't just go into the lake and say, I'm going to grab fish. Except somebody go there with specialized skill now, process that fish, and have it in the warehouse for you to buy. So that's just a scenario. So data lake, the end user of data lake are data analysts, BI engineers. These are some of the main consumers of data warehouse. BI engineers are key consumers because they go in now, take that process data, and build nice reports for stakeholders.
Branford, can you please check the chat box? There's a question there from how
Okay.
can data lakes be used for the data in analytics?
Okay. How can read it again, please? I mean, I'm sharing my screen, so I'm looking at my screen. I'm not looking at the chat box. I'm sorry.
How
Can you
can
please read
data
that
lakes be used
Uh-huh.
for the data in analytics?
So data lake allow you to store raw unprocessed data, huge volumes of data, right? And in analytics, the main usage is for machine learning, right? As I said, data scientists, ML engineers go into the data lake to identify patterns, to build machine learning models, because machine learning require huge raw data set. That's what machine learning requires. It's easier to exploit patterns, right? And to learn with huge data volumes. So ML engineer uses a data lake. Data scientist uses a data lake. So that's some of the use cases or some of the usage of the data lake when the data is in the data lake. So I hope that answers your question. Okay. So here's a scenario here for a data lake. Say we are considering AWS Redshift. It's a flavor, it's a service provided by AWS for data warehousing purposes, right? It's a data warehousing tool provided by AWS. There's something called distributed computing. For some of us in computer, we should have a glimpse of what distributed computing is. But distributed computing happens to be one of the power of cloud technologies. Distributed computing is when you have multiple computers processing your data, multiple computers, right? Because for the kind of huge data set that we're having, the kind of world that we live in now, a single computer, no matter how big that computer is, cannot process that single data, those huge data sets. So we have to leverage the power of multiple cheap computers in order to process those huge data sets. So within that distributed computing scheme, you have something called the worker nodes, and then you have something called the leader node, right? So the leader node basically is the computer that have all of the instructions, give instructions to the worker nodes, and then they do the work. When they complete the work, they tell the leader node we have completed the work. Then the leader node will give the output. That's how it is. So that's the architecture of Redshift. So we call it Redshift cluster. People within data warehouses in modern world will have people storing terabytes and exabytes of data, huge volumes of data sets in data warehouse also. So you need huge processing power to process that data. And again, remember we said there's a lot of data processing that goes on before the data is going into the data warehouse. But there's another process called ELT, extract, load, then you transform. So sometimes some companies can extract the data, unify it and load it, and they process it in the data warehouse. So it depends your approach. You need good, strong storage and computing power for your data warehouse.
Okay,
Then
so
once you have
sorry for
yeah.
okay, there's another question here
Yeah.
that says, as a student studying at a school somewhere in Africa who mainly use computers or the internet to do my assignments and social media, how to enter out or contribute to data lake and data warehouse?
So again, let me say this. Data lakes, data warehouse, data systems generally is being utilized by organizations, right? It's not something that except maybe you are a freelancer and you are hired as a consultant to do a piece of work, then that's a different thing. But data again is a very valuable commodity. It's not something that people can just allow you to go and access and just do and play with it. But if you want to learn, there are some, sample data set on the internet, right? There's some sample data set on the internet you can go take and just play around with it. But people will not allow you to use their very valuable data sets acquired from customers to just allow you to play around. So to answer your question, if you want to go into the data systems area, that's fine. There are a lot of courses online that goes deep and that will take you through, provide sample data set for you to play around with or to practice with. But not with organizations or not in the real world, except you're employed or you're hired as a consultant or a professional.
There's also a question here, but it's not really clear. Augustine, I hope you can rephrase it. Was according to what he wrote, he said, what are some of the primary and foreign keys relationship that are established through the thing? Established through.
Established where?
Yeah, that's what I wanted to rephrase. What exactly is directing your question to?
Okay. So I think I understand what he's trying to say. Again, there's something called dimensional modeling. I talked about relational modeling initially when I talk about relational database systems. But now, since we're talking about data warehousing, there's something called dimensional modeling. Dimensional modeling allow you to also, when you have processed your data, to store this data in tables. And this table that you store your data in has some connection with another table. So in dimensional modeling, there are two main approaches. There are two main schemas. We have something called star schema. We have something called snowflakes. So in a star schema, where you have where you have dimensions, you have facts and dimensions. This is very complicated. That's why I didn't bring it here. Where you have all the dimensions being interrelated with the fact via primary and foreign keys. So again, that's dimensional modeling, where you have tables being interrelated, even within a data warehousing scheme. It's not as complex, or we don't have that complex relationship as we do in relational database system, but we have a minimum in data warehousing.
So I think he brought in the conclusion of his question. He's talking about relational databases.
Okay. So relational databases, yeah, of course, we have primary and foreign keys. But that question would have been beautiful when we were addressing the relational database section. Within relational database, as I said, we have multiple tables, and these tables are interrelated. And they are interrelated via primary and foreign keys. Of course, they are. That's why now, when you are querying the data, you use joins. When you use joins, you refer to these keys so that it's easy to access data from multiple tables. Okay, so some of the benefit of data warehouse, we have consolidated data from many sources. We have historical data analysis. That's why I said talk about huge data set or huge data volumes in warehouses, because data is loaded incrementally. And so let's assume your business has been operating for the last 10 or 20 years. You should have all of that data processed and sit in your data warehouse. So it's easy to go 10 years back and understand and have insight into some of the needs of customers 10 years back. And then that will provide also some insight for you as you make your day-to-day decision. Data quality is good. Unlike a data lake, data quality is good because, as we said, there are some ETL processes being performed before the data comes into the data lake, into the data warehouse. Consistency and accuracy, of course, that's the essence of a data warehouse. To have processed, well organized. When you go into the warehouse, the literal warehouse, you have cartoons, clean, neat cartoons that are packaged, well packaged, and seated in very cool environment, waiting to be shipped. So everything within the data warehouse should be well organized, well packaged, neat, waiting to be shipped. Unless the data lake, what you have is take for example in the literal lake, where you have fish passing around. People try to clean the lake, but still people dirty the lake, and all kind of things is there. So it's hard to keep things in check. Separation of analytic processing, which is the analytic processing from transactional processing. So the OLAP and the OLTP. I say again, going back to the issue of OLAP and OLTP. OLTP is for transaction, for write intensive. You have your website, people visiting it, they're writing data to the database. That's OLTP. OLAP is where all of that data is in the database, and you take it, process it, and have it in the data lake, in the data warehouse. That's OLAP. It's easy to access from the data warehouse or to report from data warehouse than it is to ask to report from an actual live application backend database. So there are a few drawbacks, of course. Onset of data loading resources, hidden problems in source systems, and data homogenization. So basically, we'll talk about understanding of data loading process. The easier process or complicated process, you need to hire data engineers to maintain these pipelines. Also, when there's problem in the source data, it's hard to be spotted in the warehouse because once you skip the processing pipeline, even though you have some DQA process or data quality process or processing within the pipeline, but when problems skip those, you don't have a very good DQA process problem or faulty data skip those processes. It's in the warehouse now. It's hard to spot. And when it comes to data, having homogeneous data, it's a bit difficult because all the data in the data warehouse must be of the same format, right? You must have all of the data to be standardized in tables, which is a very tedious task to perform. Here, I think we have already spent a lot of time going through some of these differences or comparison. But here on the screen here, I have a quick overview of some comparison. I'm not going to read through them individually, but just something we can scan through quickly between data warehouse and databases, right? Some characteristics and some comparison. We said data warehouse is for analytics, databases or relational database are for transactions, right? Data warehouse are for bulk reading, and transaction database are optimized for write. So I'll keep this here for the next 1 minute so that we can scan through as quickly as possible and maybe gather some questions from here for the final Q&A session before we wrap up.
Okay, so guys, keep sending your questions in. From the 10 center Zoom, keep sending your question in. So I have one question here.
Yes, please.
For people that are posting on social media on a daily basis or that post maybe sometime, are they also contributing to the data lake? Or how is their data being relevant to database as a whole or data as a whole?
Okay, that's a very brilliant question. A very brilliant question. Let me say, for example, Facebook, right? We all use Facebook for free and they don't charge us, right? That's because you also provide something. There's something called data monetization. They collect your data, they use it for money. So they ain't got to charge you to use Facebook. As it relates to your question, every transaction you do from as soon as you open Facebook, you're scrolling, you're liking, you're commenting, how long you stay on specific pages, right? Facebook keeps track of all that data. So every second you spend on Facebook, you produce lots and lots and lots of data for Facebook. And you know what happened? Facebook will use that data. Facebook uses that data. They sell that data to third-party companies or to other companies who will use that data now to sell you some goods or to show you some ads. Have you ever been on some kind of site and by the time you leave from there or click on some kind of thing on Facebook, by the time you leave from there, you start seeing more ads from that people? What Facebook doing? Like machine learning, like marketing strategy. Once you look at something for long, they say, oh, they meant like it. For example, you see some kind of snake on Facebook, you look at it small. By the time you move on there, they'll start bringing more sneakers. So more I can use Alibaba. When you go on Alibaba, you leave from there. You go back on Facebook, forget it. Alibaba already they're sending you ads. So that's how they use your data. So the bottom line is we produce every second we spend on every social media, we produce hundreds of data points for these companies. Okay, so we are now at the Q&A session. Feel free, you can go on mute if you don't want to add your comments to the comment section. Feel free to ask.
Yeah, Branford.
Yeah, Israel.
Yeah, before the Q&A section,
Yes.
at the end of the day, I want for all of us to understand that, I mean, what's the purpose of establishing a relational database or data warehouse or data lakes? So remember that all these things are put into place because these organizations, like Branford was saying, they need information so that they can be able to push, campaigns or make business decision. So you are asking about, foreign keys and, how we can establish them in relational database. Now, remember, when you are firstly creating a database, for instance, at Orange, what we do is that we have several servers, to store all these different customer information. From the time you walk in the store and say, I want a SIM card, we take your information, your picture, and all of that, we store it somewhere. You leave the store, and from there you start buying bundles, making calls and sending texts. All those transactions are being stored somewhere on our servers. That's why when you come out and say, I want all those I've been texting over the last 1 month or over the last 3 months, we just go and query and send that to you. So you are every day you make call, your transaction and everything, you are creating thousands or millions of records on our end. So some of the records that we capture from you, for instance, your location, we use the cell tower to capture your location and then store that. When you make a call, when you dial USSD, we store all of this sessions somewhere on our servers. And then that's what we do to send you campaigns. For instance, you have people that only recharge $1, or some people recharge $5, some people recharge $5 and above. So when we are sending you a campaign, for instance, maybe we need people to subscribe to a specific bundle that costs maybe $1. We already know people that are recharging $1. So we don't waste time to go and send campaigns that cost $5 to people that are recharging $1. That'll be a waste of time. That's why they collect all these different data so that they can sit at the end and make business decisions. So I told you also, I said we capture your location based on the tower. That's why they build tower in the various locations, and the tower is mapped by the community or the area, the neighborhood that you live in. So when you make a call or you send an SMS from a particular location, we capture all of this information so that if we want to, sell something to people in maybe Broadville or people in Kakata, we only send them, that campaign. So we don't just, blindly send it to everybody. So that's why they establish all these different databases and all these different processes. Now, you as an engineer, as a data engineer or system engineer, you have the burden on you to set up all these different key. You're talking about foreign key, create the databases, the different fields that will be storing this information, so that as maybe working in marketing, I need this information. You can quickly be able to capture that and send it to me, and then I can target who I want to target. So I hope we have that at the back of our minds.
Yeah, but then there's a question here from someone saying, what is the disadvantage of database? I think that was from Augustine.
Of what?
The disadvantage of database.
Disadvantage of database?
Yeah, that was his question, exactly.
I mean, I can't think of any, but maybe Branford.
Israel.
Maybe using that,
Yeah.
we're using database, or what's the disadvantage of using database? Or having a database?
Quite frankly, I can't think of any disadvantage of
Me
using
too.
database,
Me too.
because
I don't think.
I mean,
I don't think
people
I have
use it
any
to capture information. That's all. Because if you don't have database in place, then I mean, people will just blindly do things.
And database, Asia, thank you so much for coming here and making those very nice comments. Database does not have to be a relational database. Database is not that of relational database systems. You have your Excel spreadsheet, you're keeping track of your monthly expense. That's a database. You have your notepad, your notebook, copy information there so you can remember. It's a database, right? So I don't want us to think of database.
Even at your house, the drawers you got, the kitchen you have, I mean, you can even refer to them as database because you use them to store different items, right?
Checking database.
Your storeroom, yeah, your storeroom, your cupboard, your drawers, everything. Those are databases.
So there's a question here from Dolo Joseph.
Yeah.
What will you do if data loss occur during data migration?
Okay. That's a great question. So again, there are different kinds of data migrations, right? And there are standard procedures or processes involved in migrating your data, right? Of course, data loss is a risk that we all, or that every company organization is afraid to encounter, but it's also always very, very advisable to back up your data, whether you are performing an operation or not. So you see, these top companies, these big organizations, they always have their data backup strategy there because anything can happen anytime. So the scenario Bob, when it comes to migrating your data, it can happen, right? You can have data loss, experience data loss, or system failure during migration, and you lose your data. If your data is not backed up to be restored, then I'm sorry for you, my friend. It's gone. So it's always very, very advisable to back up your data, no matter what. Whether you have the best systems, wherever you have your systems, back up your data so that whenever anything happens, even if the end users, right? There are some end users who have high privileges, they could perform the wrong operation. It's only backup that will save you. You easily restore the data set.
And Branford, for one example, because I work with Orange, so for us at Orange, we have physical data centers here, right? But also we have in Africa, they have a backup, a whole data warehouse there for backup. So if you have a downtime, for instance, disaster or anything occur here, you still have those data stored somewhere on the server, on the other servers in Africa. So you can still, have access to all of the data, the customer information and everything, because every day it's being replicated. Your calls, your SMS, and everything is being replicated there.
Absolutely.
Brilliant. If you have any more questions, you can send in your question. This person is making a point. Databases have some drawbacks, including potential complexity in design and management, expensive initial setup costs, potential performance, and vulnerabilities to security breaches in the public. Yeah.
Yeah, I want to ask.
Okay, go ahead.
Yeah, like just now they were kind of emphasizing on the speaker were kind of emphasizing on backing up your data, right? So if there is no possibility of backing up the data, like getting a extended drive or extended cloud where in which you will have to pay more money, is there any way to recover or lost data?
Yeah, so there's no way to recall, or there's no way to recall lost data when depends the damage. Let me not say no way. Depend the damage of your existing system that contains the data. If maybe your machine screen, for example, let's assume you have your personal data on your laptop and your screen burst, you can go change the screen and still get your data. You still have the external hard drive there. But when the hard drive has been fried and your data has not been backed up, you lose it. So let's take it to the bigger system. where you have a large relational database system in your corporate environment and there's no backup being done, which of course is very impossible to have corporate systems without backup strategies. But let's assume that's the case, right? And maybe there's a fire in the building, God forbid, and people had to escape and the building got burned down and there's no backup. All of the hard drives got burned. There's no way to recover that data. Once the hardware that contains the data is destroyed, there's no way. But in the cloud, it's different. But in the cloud, your data is replicated for you by the cloud service provider. And you yourself can even replicate it more to be super, super, super safe. So that when one region goes down, your data is still available in another region. Aside from that, on-premise, you have your data physically or on-premise, or you have it on-premise and you are migrating it, and there's no backup and there's a failure there, you lose your data, you lose it.
Okay, so losing the data and lose it. There's a question here from one Alan. He's saying, is big data a subset of data lake?
So data lake is big data. So there are a lot of approaches to handling big data, even in terms of data warehousing. That I talk about distributed computing. I talk about having multiple computers running your processes. I talk about worker node. I talk about master node. These are all within the big data context. I talk about IoT, right? Streaming data. These are all in the big data context. So yes, data lake is big data. People necessarily wouldn't even really call it a lake if it doesn't have certain volume of data, right? A data lake is where a huge amount of data is stored. So yes, you are correct. Data lake is big data.
Okay. So let's say for a small business, which database system or platform or tool can you recommend for someone operating a small business?
Okay, so Israel, I hope when you want to step in, feel free to let me know. Yeah, I hope I'm not.
Yeah, sure.
Okay. So it depends the scale of your business, right? No matter how small it is, I mean, there are still varying sizes. If you're just starting up and you mean business, it's good to set up your own small relational database. Using Excel to manage your data, you eventually have to move the relational data as you grow. So it depends your scale. You can start with specific tools. You can start with Excel. You can start with Access. You can start directly with SQL Server. So that is called let's assume you start with SQL Server, right? Because you want a system that lasts. So you start collecting your data and storing it with SQL Server. For small businesses, it's advisable that you can use any of these cloud service providers. You can use GCP, which is Google Cloud Platform. You can use AWS. You can use Microsoft Azure. All of these cloud service providers, they have their offerings. They have offerings that are very, very similar. So, for example, relational database managed service on AWS is the same on Microsoft Azure. It's the same on Google Cloud, right? It's the same on Ali Cloud. It's the same. It's the same, except there might be slight cost variations. So if you're going to start a small business, our advice is you set up your database system in the cloud, talk to somebody who has an idea in terms of setting it up. And once it's set up, they give you access. Life is easier for you.
Okay, so we have two questions here again. One from Samuel. He said, does the backup apply to private browsing as well? Like browsing in a private server on your phone or computer using Orange Internet Service. Can Orange retrieve those information although private?
Israel, I think you're talking about offline data. I think so.
I mean, the question is not very clear, but
yeah, not very clear to me too.
You browsing on your phone and what using Orange Internet?
Yeah, instead of browsing on your phone using Orange Internet Service, can Orange retrieve those information although it's private?
Which information? Like maybe you go to, for instance, Facebook.
Like backing up. Because his question was about backup.
Backing up.
Yeah, does backup apply to private browsing as well?
I mean, if you are browsing on a website and using Orange Internet, we don't have access to whatever site backend that you are browsing on, so we cannot, retrieve any backup for that particular system. But for instance, your phone, maybe your phone got damaged and you want to, get all your contacts you've been, contacting for the last 3 months or the last 1 year, you can come to Orange and we can give that to you because we have all those information.
Okay. So I think there was one more question. What security measures should be taken to protect sensitive data stored in a database? Data security.
Branford. Okay, Branford saying, okay, for security, like Branford mentioned earlier, it depends on the provider that you are establishing your your database or whatever data integration with. They have some security level of security in place, but from your end also you have the responsibility to protect your data. That is, refrain from sharing sensitive information from people outside your info or your organization, or else they may have access to your database and retrieve information that they are not supposed to retrieve. Also make sure you have updated hardware policies in place. I think every year or every quarter you have these database applications deploying new updates. Make sure you update your application regularly. It's very important because what they do is that they update the application hardware, software, so that in case there any security loop, they close that. That's one of the main reasons why they send an update every time, because every day you have these different hackers trying to penetrate these systems. So once they take notice of it, they try to put steps in place to block them, and then they send out a new update. Make sure you are using the recent version of these softwares. So don't say, oh, every time the people just sending us new update. Make sure you update. If you notice, Apple, I think they release every 2 or 3 months, and all these releases are meant to apply patches to all the different glitches or loopholes. So it lasts on you and also lasts on the provider. But make sure you're up to date with all of the policies.
Okay. Thank you so much. So that's all for today for our speakers. Sending as usual, your thank you messages and appreciation to our speakers, Branford and Israel, for their contribution in a lecture on data system. At least now you know that even your drawer that is in the kitchen can be considered a database. And you can just go there from database one, you can get a Coke spoon, So database is in different dimensions. You can get database or you can utilize database in many ways. So probably your partner's pocket could be your database. You could get $5 from there, or your partner purse could be your database. You could get maybe $10 from there. So it depends what you get, how you're building a database. You can build a partner database by adding more money. Maybe your wife or whoever, you can add more money to the database. So that's it. Thank you so much, Israel, and thank you so much, Branford.
Okay.
You were with us the last time, and I appreciate your presence being with us, always trying to share your knowledge and experience when it comes to what you are good at. So thank you so much. Hope that we can again collaborate with you in upcoming sessions. And from our end, we want to say thank you so much.
Okay, so it was good being on. If you have any further questions, don't hesitate to reach out. Branford is on LinkedIn, Branford T. Gbieor. I'm also on LinkedIn, Israel Z. Kollie. Or you can also find us on social media. Just get in touch and we can establish partnership.
You single?
Okay, so that was said that from my
Question?
Israel, from Israel, Brentford. Dana back we hear that question that you need to. So that's it. Thank you so much. Guys, I think some of you joined late. So let's just take us back a little bit. So tomorrow we'll be having our last speaker for this year OSCC, and that would be Dr. Ahaji. So tomorrow we have Dr. Ahaji, who will be coming on to give his presentation. He's going to be ending the session. You have already messaged me that he'll be talking on IP surveillance tomorrow. We have had all of our speakers for the days. So if you just joined, and I think yesterday we talked about this Huawei developer competition, you can scan the QR code here and then join a group and get all the information from there. If you consider maybe what will be the price or incentives, there it is. You can take screenshot anything about it and share with your friends. So we have started the process of certificate. Let me show you something here. We have already started working on the certificates. So all the volunteer certificates have been prepared. Likewise, all of the speakers certificates are ready. For the participant, we started with some of you, hoping that you will end all of the 5 days, including today and tomorrow. So if you're done, and probably your name is here, like maybe Sudu, his name is here, or Shilin, and then you don't complete the 5 days or tomorrow. Obviously, they won't I'll just use shift, and the name is here permanently. So I'll not be able to retrieve even the database. So try to attend tomorrow to complete the 5 days so that you can be awarded your certificate. Hopefully by tonight, we'll try to complete all of the certificates for those that have completed from day 1 to day 4. All the certificates will be ready. And tomorrow we'll show you how far we have gone with the certificates preparation. So if you know you have attended or you have missed 2 days, don't bother. So let's take our attendance and call it a day so that we can go and rest and get ready for tomorrow. You can turn on your cameras so that we can take our attendance for today. If you observe the microphone is muted for all of you guys on Zoom. After the attendance, I will open it. So please open your microphone and your camera. Let's take your attendance. Yeah, 10 cents people. We're already taking that. Don't worry.
And but somebody just sent message saying they're not permitted to open the video, so I don't know what it is.
Yeah, it's okay. If you don't want to open the video, it's okay. Once your name is showing, we'll also work on it like that. I'm coming. Let me open the video fee. I'm coming. Okay, now you should be able to open your video on Zoom. Let me open it also from 10 cent people. I'm coming. Just a minute. Let me open that. Okay, 10 cent people, you should also be able to open your video from 10 cent. You can also Let me also do something. Okay, so I think both platforms are okay. Now let's take our attendance for the 4. So once you complete tomorrow, the certificate will be ready. You don't know which screen you are on, so please just remain in that position. And then, okay, I've taken the first screen. And like I said, you don't know which screen you are on, so let's stay there, Vicky. It will not be long. I'm taking the second screen now. Okay, second screen is taken. Let me take the last one. Okay, taking the last one now. The last one is taken. If you think probably you were in attendance when we did it, and your name is not captured in the PDF we usually send, go to YouTube, and then you watch the video. You can skip the video at the very end. You will see where we are taking the attendance. So you can just pause it and maybe let us know, oh, I was in attendance, but you see, you never put it in the PDF. So it's another way to verify or tell us that, oh, maybe we made a mistake on you and all of that. Yeah, 10 people, you are good to go. Zoom people, now I'm going to end the recording.